Software doesn't last forever. Or does it? Hi, my name is David Webster, and I'd like to introduce you to my virtual computer architecture, TPCPU. TPCPU is a tiny, easy to re-implement virtual machine for hosting software, especially development toolchains, which will never suffer dependency outages or drift off into the empty void of non-reproducibility. It's a way to host not just individual programs, but entire operating systems and toolchains in a box that can be analyzed, proven, and reproduced trivially. For brevity and clarity, let's quickly talk about what TPCPU is and what it isn't. TPCPU is, or will be for things I haven't implemented yet, a tiny, reasonably fast interpreted language which a competent programmer should be able to fully re-implement on a new platform in assembly language within a day or two. A way to host permanent code. People 50 or 100 years from now should be able to run your exact, unmodified binaries and get the exact same answers with relatively little effort. A way to host highly deterministic, reproducible code. TPCPU would be a fantastic way to formally verify algorithms and programs in combination with a proof assistant like Coq. This is absolutely essential in zero failure tolerance environments like aviation and medicine. And TPCPU is possibly the fastest and easiest way to bootstrap and port a robust, multi-process, preemptive multitasking operating system to new and undocumented platforms. While I have not written an operating system for it yet, the capability is there, and I plan to do it. TPCPU is not a fantasy console or retro throwback dream computer. TPCPU may have similarities to some historical computer architectures, but these similarities are superficial. A toy implementation for teaching CS students how computer architectures work, or for researchers to play with in a lab. This is built for real-world constraints and uses. A RISC ISA to be implemented in silicon. This architecture was designed from the ground up to be fast and easy to emulate. Its intended implementation is a token-threaded bytecode interpreter. It is as simple and capable as possible with the least amount of emulator implementation effort. As such, it does not feature the same trade-offs that a hardware RISC architecture typically makes, such as fixed-width instructions. First of all, I've implemented the architecture twice in C. I have a version using switch case in a while loop for total compliance with C89, and a version implemented using GNU-C's labels as values extension and computed goto. Here's some sped up footage on screen of the self-hosted assembler optimizing and assembling itself. It's a full bootstrap build. The optimization pass is quite rigorous, so it takes about 23 or so seconds to compile with this emulator. I'm also writing a manual. I've documented the entire ISA, privileged mode, switching into user mode, the devint instruction, and lots of other stuff. If you want to learn about the architecture, this is your primary source. It's a work in progress, and I edit it as I go along. Later, I will go back and completely finish the manual. As mentioned before, I have a self-hosted assembler. The assembler is written in Coder's Basilisk, my personal lingua franca of programming and C replacement, and then compiled to assembly. It can assemble itself perfectly, down to the last byte. I have a code generator for Coder's Basilisk, which generates TPCPU assembly code, which can then be assembled by the assembler into an executable ROM, along with a tiny standard library I wrote, which, among other things, includes a pretty small and clean malloc-free implementation, along with a serialization quality fixed-point string conversion library. I also have 2 sample assembly programs to show off the syntax and semantics of the assembly language. There should be more in the future, including example uses of privileged mode hierarchy and instruction set tests for VM implementers. That's what exists already. Now let's talk about the plans for the future, starting with the very next thing to implement. The next immediate step for this project is to get a high-level language onto this ethereal machine, which compiles to TP-CPU assembly language. You can't write good programs without a language. I'm working on that actively. I won't get into the weeds, but it'll be a C clone with cleaner syntax and some simple object-oriented features like constructors and destructors. It will also get both a kernel mode and user mode standard library. I'm thinking about maybe adding templates too, as sort of a preprocessor type thing, but I don't know if I'm going to do that. A tiny OS. After that language, the plan for the project is to write a kernel, a shell, core utils, and some example programs, a complete operating system, and dev kit. Plans for this are not yet well formed, but I know roughly what to do. Concepts of a plan, if you will. This should also provide a substantial amount of example code for the platform. After that's done, the project is pretty much finished. That's version 1.0, ready for production. Let's talk about what this is for. In short, permanent, verifiable computing, time-proof implementation. People 100 years from now can take your exact binaries, your byte-for-byte exact same source code, and run it verbatim and get the exact same results you did with 0 deviations. It's great for formal verification. An implementation of anything in TP-CPU could be analyzed by a proof assistant like Coq or Code Analyzer, and you could prove certain constraints. Security is also a great use case. TP-CPU provides a known trusted way to host programs in a sandbox and observe them. You can even use the user mode as a sandbox within a sandbox, right? It should also work really great for embedding in games. It's a great higher speed replacement for Lua and an easy way to run untrusted user-written scripts or plugins using TP-CPU's built-in user mode sandboxing. You could also use it to have virtual computers in your game, which run a real operating system and people can write real programs for, like Redstone in Minecraft or WireMod E2 in Gary's mod, but cooler, faster, and lower in overhead. If you are interested in the project, leave a comment and a like so that people see the video. This is all public domain code. The emulators, the assembler, the code generator, everything. Even the logo. Totally unencumbered. Totally unencumbered. You don't even have to credit me. I do want you to credit me, but you do it because you want to, not because I legally require it. If you are a compiler dev or a systems programmer interested in the project, consider forking the project and writing new tools for it. Even if all you can offer is improvements to the standard library or code optimizer, that would be great. Hope to meet again next week.